Hi folks, so welcome back again to one more series on backend app development, manual testing and automation series. So this time I'm covering the GraphQL related backend development and the manual testing, postman testing and then automation. So everything will be done via Google Gemini AI powered, and there is a simple prompt I have come up with, and with that step by step we will discuss how the app is developed, how I have tested and how I have automated. And this entire code is available on GitHub. The link, everything I will be putting in the description. So let's get started. So before that, let's start with some theoretical concept. So GraphQL, it's an open source query language for API. uh, s- so normally it is compared with REST and GraphQL. So we'll see that GraphQL, it lets client ask for exactly the data they need. So that is a plus point. There's no overfetching, there is no underfetching. Exactly what as per the query you have to provide the data and you will get the output. Okay, so just a comparison between REST and API. So in REST, it is basically resource driven. So for every individual resource we have to call the API and then we'll get an individual response. Whereas in GraphQL, we can get a consolidated response, basically a query output. So the beautifully you design the query and pass it on, you will get the required output. So that is the advantage. If you see between your client and this individual services or database, there's a GraphQL in between, and that will handle all the work. So of course it has its own advantages and disadvantages. So by default, HTTP post method is used for GraphQL. Yeah. So again, same technical example. So in REST we have GET API and we have a JSON and all. So here the thing is, if you want to uh, get the data for user or person one, then you'll get all the data in one shot. Okay. But if you see the in the GraphQL, you will get similar data, but then you can filter it, like you only want the first name or last name and so on. We'll see much more detail technically uh, going forward. So how it works, GraphQL APIs are built on a type system and a schema. So schema is basically a contract defined by the server that lists all the available data types, for example, user or a project and their relationships. Then we have something called as resolvers. So resolvers are functions that on the server that fetch the actual data for each field from various sources like databases, other APIs, and microservices. So we see that example. Operations. So client interact with the API using three main types of operators. So we have queries, um, similar to your REST GET request. So it's basically a query language. So we have a query. Then we have a mutation. So for creating or updating or deleting the data, similar to post, put, and delete, as we see in the REST. And then subscription for receiving real-time updates over long-lived connections, typically webhooks. So we will see these queries and mutations basically in this session. And of course, the schema resolvers. So key features quickly. So it's a single endpoint. So there's a slash GraphQL, and that is the endpoint we have, and that's it. Because here we are not playing with the endpoints, we are playing with the query. So all the operations usually go to the single URL, regardless of what data is being requested. It's just that the query is different. We want to have different data, strongly typed. So if every field has a specific type, allowing for automatic validation and better developer tools. So because it is strongly typed, so we define each and every variable type and each variable name and its type. So there is very less chance of error. Introspective, you can quickly you can query the API for its own schema to see what data is available, making it self-documenting. So we don't need additional documentation because it is strongly typed. Versionless, instead of creating new versions like slash v1 slash v2 APIs, uh, APIs evolve by adding new fields by duplicating old ones without breaking the existing queries. Okay. Now some disadvantages. So complexity overhead, because we always have to have a fixed query. The if there is a slight change in the requirement or as per the business need, then there is a little complexity involved, and then the development and automation both has to uh, talk to each other and then get it agreed. So that kind of overhead is there. But if you have fixed query, then it works perfectly fine. Potential overfetching for a poorly designed query. Suppose the query is ambiguous. For example, you normally say select star from, let's say, user where name is this. So, if the usernames with if the user are if there are usernames duplicate, or the query is not designed properly, let's say it's a big query of inner join, um, outer join, and many other things, then it is overfetching. Sometimes this extra data handling is again increasing in bandwidth, increasing the traffic, so that kind of complexity is there. uh, Caching challenges. So REST API, as we know, it has a lot of caching mechanisms already implemented in different systems. So if it is REST API, then the caching is already available. But that is not the case for GraphQL. So that is again a challenge. Again, it will increase bandwidth and cost. Schema design overhead. This is again related to the first point, complexity, because if there is a slight change in the requirement, it is not that easy to adjust. Though we are seeing a very simple example, but in practice there will be tens of hundreds of queries we need to agree between two systems and then the schema. So if you change one query, or at one place there is a change, then it might impact other places also, and then that becomes a overhead. Learning curve, yes. Traditionally, like most of the developers and QA, they're well versed with REST API testing, REST API development and all. So there's a little learning curve, right? Now, yeah, so in demo, what we'll see, so Google Gemini is the AI tool I have used. It has assisted. I have given a small prompt, and then there's a conversational AI going on, and then I've came up with designing and manual and automation testing. We'll see a simple query. It's a basically post method. Then we'll see nested query, like there is a uh, product, then we have a product supplier, so supplier maybe multiple suppliers, so that kind of nesting is there. We'll see filtering, selective query with limit keyword, so basically a SQL or a query thing. Then error scenarios, response, code and body. Get method, normally we don't see this in the GraphQL, but we'll just explore. Then the schema file, which is a GQL file, and then manual testing and Postman, using Postman, and then the automation. This also automation is also done by Google Gemini. So let's get started. Right. So this code is available here, and if you see this dev one, so there are different folders. So 00 is very basic, and then little more advanced, and so on. So this is a PPT, the same I'm explaining here, and this contains all the prompt which I have asked Google Gemini. You know, let's get started on. And also this prompt link is also available here. Yeah, link is also available here. I've opened it in incognito, so anybody can, without login also, they can see how the stuff is being developed. So let's get started. So we'll see how I started. So apart from REST, I wanted to have some backend available for GraphQL, and then I want to develop it and then test it. So I was not having much background, so I asked Gemini what are the things required for GraphQL related app development and all. So it came up with this list. There's a, so the we need to have schema, then access, endpoints, and there's a query mutation. So that I have studied separately. Um, Authentication, this thing I have not covered because it's a very simple app for now, but maybe we can take it later. So the agenda is to understand GraphQL and then test it. Okay. So high level architect automated architecture, that again I skipped it. It's not that much I wanted. The GraphQL definition, that is helpful for making PPT. GraphQL versus REST. Okay, we have seen the screenshots. I've seen a basic query, like if there's a user data, so user, and then its title, name and title, and then there's an ID for every user. JSON, okay. So realistic module or project where GraphQL is more beneficial as compared to REST. So I wanted a practical, realistic place where it can be used. So it suggested me for your modern e-commerce product detail page, where we can fetch the entire or the required product information when a user is on the product detail page. Let's say a laptop on an e-commerce website, that person goes to detail page of that screen, and then we want to fetch all the data uh, at one shot, so it will save time and many other benefits, right? So if you want to do that using REST, then maybe you need to call multiple APIs, but then that single handedly can be done using GraphQL. Okay, under fetching, overfetching, so that kind of things are not there, right? So this is again the supportive data, right? So based on the context of our discussion, please design a simple Python and Docker based project. It is simple e-commerce, Docker based Python language. Uh, so when the user hits GraphQL query, it returns product name and product price. Simple. Provide the entire code and required GQL file. Okay. So it gave me this with proper folder structure. So I will explain that here. Okay. So same folder structure. So um, let's see the requirement, the GQL file. So it simply has one query, product, which is having IDs, ID, name, and price, and the return is only the product, full data of the product. Okay. Then we have Docker files. It is simply a Docker which is having Python, and then it will just install the copy the requirement file, install the requirement file, and copy this all the files in the Docker container. Okay, and then start the main.py. So main.py. Um, so in the main.py, I have some sample data. So I can fetch this data from SQL or some kind of a database. But here the agenda is not to explore the database to understand the GraphQL. So I have taken a fixed data all the time, right? And the resolve product. So these are the resolvers what we were talking about. Resolvers. So whenever the query is hit and it comes to the backend, then there's a resolver. So as of now, this resolver is very simple. It will just uh, products from the products DB. It will just fetch the data for the given ID. Okay, so this is one record. This is one more record, and so on. Okay, rest of the things are standard. I didn't explore much. So the thing is, I just wanted to have it up and running so that I can test it, right? So schema file, docker file, yeah, docker compose, again docker compose build, simple command is there, right? So let's get started. So I have the docker installed, docker desktop, and there is no image as of now, and there is no container as of now. So we'll start with the first one. We'll go to 00 gql 0. Okay, and simple docker compose, docker hyphen compose space up space minus minus build. So to download the image, Python image, copy the code and then make it up and running. Okay, we need to note that this localhost IP address, as mentioned in the Docker Compose file, it is on 8000 port. Okay, so right, we'll open the Postman. This is also available in the GitHub repository. So the first thing is the 00 simple GraphQL request. So here we need to note that if you want to create a GraphQL instead of say, the normal HTTP, we can go to GraphQL and then go for it. So the same thing, if you see this symbol, so that's a GraphQL request. So it has the schema. We just refresh the schema, okay, and uh, query. So I want to so this is IP address and only one endpoint, okay, and then I want to query for product one. Okay, so here's the query, right? So we got the info, we got the response, so it will be always 200. Okay, and we got a valid response. Okay, the only data we have, the two data we have, so that is available. Okay, right. So couple of points here. The URL, we need to make sure it should be correct as given here or as given in your documentation, and there is only one endpoint. Now if you see this query, so this is what is always matters. So the query is agreed between two parties, or let's say between two systems, or even let's say between developer and QA. So this query we need to get it documented and get it confirmed. Most of the time the query fails, or we pass incorrect data, or we expect something and we are getting 200 but the data is not proper, and so on. Just for the sake, I will say I want the record of number 10, id equal to 10. So now you see we are getting 200 but there is no data, because if you see here there are only two records, right? So there is no record with number 10, and so on. Okay, right. So that is for 00, and now 01. So now let's see the next one. So let me stop this first. Docker control C. I go to the GQL01 folder. So similar folder structure, same folder structure. The change is in the GraphQL file. So I have added one additional field called a supplier. So the earlier, for a product detail page, there's only name and price. Now there's a supplier, and supplier will have um, company name and location. Okay, so two additional fields and one uh, basically a collection of two fields. Okay, and that is passed on here, and the return is only the product which will have all these things. Okay, right. So now main file. So here if you see, now this is getting interesting and bit complicated. So I have four records. Okay, um, for supplier. So as we have seen, we have added supplier which will have name and company name and location. So one supplier will have some ID and company name and location. Okay, and so on. And I have a product where there are two records as of now. Okay, which is having ID, name, price, and the supplier ID. So supplier IDs are fetched from here, S1, S2, like this. So as of now it is hard coded. Again, we can do it from database, but for now it is hard coded. And of course the resolver part. So the resolver part, earlier it was just getting the um, product. Now there is bit complex, so it will get the supplier IDs also, and it will pass on the supplier details along with the product. Okay, so return type is product, but it is also passing the supplier IDs. Okay, now let us see. So for this API, okay, this API we have seen there is not much data available. Okay, there are three records, only name and price. So now let me go to the 01 folder. Okay, and then once again docker compose up. Okay, 127. Let's go to postman, and for the 01, so first let us do the simple thing, the post method GraphQL. And if you see the query, so I am raising a query with product id and product id 1. Okay, so right, so I have got the proper info. Okay, right, and get call. Right, so this get call is always going to be a standard response. And as I said, normally the get call is not entertained, we have to work with uh, the post API only. So always the GraphQL, or by default it will be the post API. Okay, right. So if you see here in the logs also, you can see we have fetched the uh, GraphQL only. That's it. Just post GraphQL post API. That's it. Okay. Now, okay, let's proceed to the third one. So third one is basically we can have a nested query. For example, name, price, and supplier. So in supplier we have company name and location. Okay, and we can see filtering. So that we'll see, right? So let me do the setup first. So I'll go here, Control C, stop. Let me just delete the container and images just to start fresh. Image. Okay, and okay, so let's do one thing. Just for part one, there is one thing which is left to demo. For the part one, if you see this product, right? So we have seen that in the code we have the supplier details also, right? Supply details. So that details are also coming. So earlier we were having only name and price for the product ID one, but now we are getting the supplier also. So we are getting three suppliers: company, location, company location, company location. So these three are coming from here. So for the product ID one, S1, S2, S3 is there, and for product ID two, we have S2, S3, S4. So three should be there, right? So these three are coming in the response. Okay, and next filtering. Okay, so filtering is again with the ID one only. Instead of that, we go for ID two, right? So we got for the this second product. Okay, wireless mouse, and so on. Okay, so filtering, we'll see detail here, so stay tuned. Filtering, then filtering with a variable, and filtering with a limit keyword. Okay, so for that I have to go to 02 folder. So 02 folder, main.py and GraphQL file. Okay, I'm in the 02 folder and Docker Compose. Okay, so meanwhile let us see. So there is a limit related query also being entertained now. Instead of getting all the suppliers, I want to get only two suppliers, or the latest two suppliers. So that is again we have to design the query. So if you see um, the query management uh, complexity is increasing based on what changes you want. Okay, and for now it's very simple, but then later on, if this product is being if this supplier is being used at many places, then again the other consequences we need to handle, right? So if you see the main.py, here we have resolvers. Okay, so here in the resolvers we are handling the suppliers and the products and location also. Okay, right. So this is started on 127.0.0.1. So let's come here and filtering. So if you see here, I want filtering as of now because it's the generic query. I want it for first product, product number one. So right, filtering with location. Okay, unknown argument location on field product dot suppliers. Okay, so location to give id and location is a string. All right, so uh, there was a kind of a glitch in the query design, so I'm back now. Now the thing was, we were trying to do filtering and selective query. So let's go to the code, and in the code, if you see, let me first check the Docker is running. So there is no container, and the image I'm going to delete. So everything fresh now. So let me start the Docker first. Okay, so it started. Now if you see in the main.py, again this is bit related to coding, but just will understand. So in the resolver method or a function, it needs product object location and limit, but that was kind of missing here in the graph, in the schema, where it was only mentioned the limit but location was not mentioned. So the postman collection was designed based on only limit, but there was no location, so that is a problem. So now this is added. Now location variable is added as a query, and then if you see, I'm going to the this limit keyword. So first we will do the API calling for a particular product ID and a location. Okay, so in the code, if you see, we have location as California, right, and we have ID as 1. Okay, so let's see. Let me just clear the response and then hit again, right? So the selective query is working, the filtering is working for a given product ID and location. Let me try one more thing. So I will go for product ID 2, and there is no location for California, so we should get suppliers as nothing because there is no supplier matching with this criteria, location as California. If you see in the code for product ID 2, which is wireless mouse, S2, S3, S4. So S2, S3, S4. So the California is for S1, right? So that is not matching. Hence, it is not giving any supplier response. Okay. Now, same thing is also automated using Python code, and this is also available on GitHub. So I will have a separate project for automation. So in the automation, there's a conf test. It's some standard thing. We need to give the URL and those thing and query and those thing. And this is also generated from the Gemini. I just have to give Gemini uh, the schema file and just have to say that come up with positive and negative test cases. Right. So this file will have the test. So let's see one by one. So positive test cases, again it's a PyTest based testing. uh, get product detail success. So again it depends on the query. So here I'm just passing the product ID, so product ID as 1, and that's it. So for the first product, whatever details are there, every details, all the suppliers, there is no limit, it will receive. So run it, right? So it is success, and I think it didn't print the output, but yeah, it got the all the details. There are assertions. So yeah, then limit. So now let's see the limit. If you see the query, there we have supplier and we have a limit, and so limit value is only 1. So the final thing is we are passing ID 1 and only one supplier, right? So again there are assertions and all. So let's do one thing. In the response, we'll put a breakpoint. Okay, so response.json, we will see response.json.data. Okay, so we have a product and we have a supplier with company name as this for the given criteria, right? The criteria was only limit one supplier to only one, right? So we have only one supplier. Okay, now there are assertions, so let it continue and it will pass. Same thing, the invalid product ID. So we are passing ID as 999 and we should not get any uh, data. Right, so that is also passed. Let's see that in the postman also. In the postman also, if we are passing the product ID as 200, for example, or 2000, then we should not get anything, right? So we are getting null. Okay, as I said earlier, the response will be 200 okay always, but then we need to check the response content. Okay, now next one is some violation error. So verify that the requesting a non-existing field returns an error. Okay, so here we are passing product ID and the field name is non-existing field, so that doesn't exist. Okay, so if you see here in the schema, in the product, the field are ID, name, price and supplier. So there is a field called as uh, we are expecting to a field as non-existing, so that will not happen and it will give 400. Okay, so there, that is passed, assertion is passed. Okay, so that is all about querying and filtering, um, and having a limit. Okay, now we'll go to the next one, which is GQL4. So in GQL4 we will see the schema first. So schema is, there is an int. So again I think here mutation, so we are doing mutation here. So basically we want to, so if you see main.py, there are products and there are suppliers for a product. Okay, now what we are doing is we are doing a mutation, that is we are deleting a product. Okay, so this is again, so as compared to rest, we have a delete method where we can pass a product ID and it will delete. Instead of that, in GraphQL we can so what we have to do is we have to have a schema and where there is a mutation and we have to pass the ID. Okay, almost similar but it's a different approach, right? So for that I have to stop the docker. I have to go to the fourth folder, so cd gql04. Okay, and then again docker compose up. Okay, so it started. So let's see the postman thing first. So in the postman I have a in the fourth this thing, there is a get all products, right? So here I'm passing the product ID as one, that's it, or get one product. Okay, so for one product these are the details. Okay, instead of get all products I'll say get one product. Okay, now what we're going to do, we're going to delete this product. So for delete, only thing is we have to pass, instead of query we have to pass mutation and then this function and then the ID. Okay, so delete, right? So 200. Okay, and delete product equal to true. Okay, fine. Now if you want to do the get again, because the same product ID is there, so we should get null because we deleted the product, right? So that is the mutation part. Now let me stop it and docker compose down. Okay, delete it once again. The container I will delete it. Delete image I will delete, right? And I will start it again. And this time instead of doing testing via postman, I will do it from automation. Again, automation is developed by the Gemini only. So second automation, by the way, this all the things are available once again. Yeah, automation 1, QA1, QA2. So QA2 we are running now. So in the QA2 there is only one thing called as delete. Again you can repeat the get one product and uh, delete any of the products. Instead of that I'm just saying mutation delete a product. Okay, so delete a product. Okay, delete product was successful, and in the response there are assertions, so that worked. Now just to cross check whether it exists or not, so we'll do a get from the postman. So again, get one product id 1, so we should get null. Okay, just for the sake I am saying that get product id 2, so second product should exist. Yes, second product exists, right? So if you see in the code, the first product is deleted but the second product still exists. Okay, so that is all about uh, developing from scratch, manual testing, exploring different query type, filtering this thing, and then deleting. We have seen the different mutations. Okay, and yeah, we have seen it in Dockerize file. Okay, yeah. So that is all about the GraphQL. Thanks for your time. Please like, subscribe to the channel. Thank you.